Hey, I hope everybody's having a great day today. I am. Where do we start? So, as you know, with me, one thing always leads to another, right? So, I'm just gonna picking up off from my last video. I spent all the other day yesterday playing Roblox. I'm not even gonna hold you up. I was playing a game, so I was like, I ain't making no video today. But when I was doing this page and I was explaining it, what caught my attention over here is that how I was saying, like, how blood, sweat, tears, and semen gives demand, keyword demand, to time. So I was like, okay, it's a system of cycling and recycling energy from host to host, pretty much. And then there's just two different hosts. One host is an attachment, one is like the guardian or the two sets of hosts. I'll further explain that. I haven't had any sleep yet either. I've been having so much fun learning again what I don't understand just yet. But just that what I was saying about here about for the demand for time, that's what made me start thinking about, supply and demand. So I have supply and demand equals currency, aka bread and butter. And don't mind karma. My mind just be going through different little stages here. I be working on like different things at different times. So don't mind that. That's for something else. So when I'm like talking about supply and demand, right? So supply is like the need. Demand is the want, right? So the need in this situation, in the bread and butter, the need would be bread, right? And then the want would be butter. So bread is already palatable, right? You can eat bread just by itself, but when you put butter on it, butter gives it like more desire, more flavor, more taste, right? It makes the bread, like I was saying, like more desirable, right? And just looking at like just bread for itself, like, the basic ingredients, to make bread, just water and flour. You can also use yeast, but just water and flour and water, you can make some basic bread. And then also just looking at bread as the laborer. And then, okay, bacon. Okay, so what am I talking about right here? So boom, when I was thinking about bread and butter, this nursery rhyme popped in my head. The pat a cake. So pat a cake, baker's man. So when you patting a cake, that's the bread, the supply, the need, right? So pat a cake, the baker's man, that's the labor and the laborers, because he gotta work, make it, and da da da. So the baker man is the laborer because he does the baking. And then bake me a cake as fast as you can. That's a demand, right? And then roll it, pat it, mark it with the B. That was like initial or a mark of the blank, right? But no, your name or your A man, just your name, boom. And then put it in the oven for you and me. And so in the oven, you bake it, everything comes together. So that's why I'm looking at it now like capital and labor. Don't mind me, but just capital and labor, just from the bread and butter. So then I was like, okay, so bread is the physical substance or material being bought to the market. And I started thinking about the three little pigs. I don't know, weird stuff up in my head, but just bear with me. So I said it takes raw materials, labor, and capitalism to exist. They mirror hard costs of the supply side. Blah blah blah. Butter spin. Okay, so that's pretty much what I just explained. So then boom, jumping down here. So that's why I said, like, without the bread or without supply, you would have nothing there would be no need to sustain a market. So without bread, there would be no need for a demand for butter. So without butter or the demand, the market is dry and just unappalling, right? So then I'm thinking back up here to bread, to the raw materials here. And then, so of course, water, bread is right here. Then I was like, okay. And then, like, my little inside joke, I always say, like, the story about Jesus with the 5 loaves of bread and the 2 fish in the water. I was like, Jesus made them a fish sandwich. It's like a fried fish sandwich, and they needed the water to wash it down. But I have many, 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 many inside jokes surrounding like a lot of Bible stories, and many for the same one. But anyway, so I'm looking at water, like it goes in a bowl, boom. But anyways, but water would represent the all in a sense, right? The bread, the 5 loaves of bread will represent the body or the 5 bodies. And then the fish will represent your spirit and your soul. So with the 2 fish being split in half, just showing you like your spirit and your soul, it's all inside your body, and that's surrounded by water. Boom. So then when I thought about like the 5 bodies, like comparing it to that, so I was like, a body got to have a face. What has 5 faces? And the first thing I could think of is a clock. So that's why I said like a 5-face clock. Time has many faces. So then boom, how did I even start this? Okay, so just dividing time into 4 parts of the day: morning, noon, evening, and night, right? So morning, or so, morning, noon, evening, night. That's why I was like, why did I do it like that? But and then the 24 hours in the middle representing 24 hours of the clock, right? So each quadrant pulls from the middle, right? They pull out the 24 hours, and then they all somehow share the day. So then I was just like, okay, so we're going in 6-hour intervals, right? So that's the way I was looking at it. And then north, east, south, and west. And then this is just me thinking with time, right? So what I pulled out of all of this is that that pretty much the moon follows the earth traction, right? Because at first I was thinking like the moon mirrored the sun, but what I got from this is that the sun and the moon, they both share the same light. And I don't know how yet to prove this, but I know I'm going to get to it. I know I am, and I know I am. But just looking at this, that's why I said like earth spins from west to east. The sun rises from east to west. So you're thinking from west to east, that's the rotation of the earth. And then the sun comes and go this way, but don't go down this way. So I might do the sun, just do 3 rotations, go back into here. And then when I'm looking at the planets, I'm like, okay, you know, the sun goes here and then do a rest in Pluto or Neptune and but that's just me. I think I started working through that a while ago. I just probably never went back to it. So then I'm just thinking about, okay, because I know like on some maps that I've seen in the past, this was east, this was north, and this was south. And north, north, south, east, and west. So I always play around with both because, you know, 2 things can always be true at once. And that's why I like my inner workings here. So when I'm saying here that true north is just a fixed direction pointing straight to the geographic North Pole along the Earth's surface. And what we got down here leads up to the permanent top. Okay, so that's just true north, and then there's magnetic north. So that's just what I was explaining, that we know that the moon is magnetic, earth is electric, but they're both honestly, but I'm not going to even get into that because I don't want to switch y'all up just yet. It's probably going to break down into pieces. But it shows that the magnetic north, that's where it's constantly changing because it follows the Earth's core and not the geographic core. So if you following like a magnetic compass or fixed compass, you might get 2 different locations because magnetic goes by the Earth and then the compass goes by the sun. I might have said that backwards. Don't quote me. I haven't had any sleep just yet. And then over here, boom, I'm playing around with the numbers because I'm still fixated on time. And I had made some mistakes. So I was just like, let me move over here. And I tried it again. I made some mistakes. So I was just like, you know what? I'm not going to keep wasting paper. It happened. It was a mistake. Scratch it out. So anyways, so this over here, this is military time starting at the 0 hour. And then we know like after military time, when you get to the 23rd hour, 23, that's 11:59. It doesn't go back to 0, or it does go back to 0. It never says like, oh, I'm 2400 hours. It just goes back to 100 hours, right? So then this is just me just working it out. So then now I compare standard time to military time, right? Just starting. So in standard time, 1 o'clock, or let me fix my camera, 1 o'clock or 1 p.m. will be 1300 hours. So then I just added the 1 and the 3. That's where I got the 1 and 4 from. And then still in standard time, 2 o'clock will be 1400 hours. And the best way to help me always remember like military time, like off the top of my head without like trying to count on my fingers, I always take whatever the hour is and minus 2 in my head. I don't know, that probably don't make sense to some, but to me it makes perfect sense. So like for 1400 hours, I'll say minus 2. That'll give me 12. And though I know that 1200 has its own time, 12 o'clock is 12 o'clock or whatever. So that makes that I just drop off the 1 and then keep the 200 to tell me that's 2 o'clock. 1500, I minus 2. I don't know. It makes perfect sense to me in my head. I just be knowing. So I just drop off the 1 and keep the second number, if that makes sense. But it makes perfect sense in my head. Like, oh, what's 1800 hours? I'd be like 6 p.m. What's 1900 hours? I'd be like 17, because I just subtract 2. I just know, right? That's just my way of thinking. So boom, 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 boom. So then again, thinking about time, I was curious, like, how would time look written as an interval of time? So we know that you don't have 3, time is just 4 digits, 2 on each side, boom, 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 boom. So it's 4 letters, so that's why I just separated it between the I and the M, right? So TI and then ME. So then I wrote down the numeric values for this. So for T is 2, I is 9, M is 4, E is 5. So then, because I was thinking about military time up here, curiosity always creeps into my mind. So I was like, okay, so if 2900 was written in military time, so 2945, and I'm like, what time of day would that be? Like, is that even possible? Like, you know, do people even talk like that? Like, you know, meet me in 2900 hours. Be like, oh no, bro, like, nah, I ain't doing that. 2900 don't exist. So this is just me curious. I put 4 here, but I know it's really 5. But as I said, I haven't had any sleep yet, so that's why I was just slowing down a little bit to check my math, and I had caught that mistake that I made. So this is what I did. So let me show you, because I did it over here again. So right here, so just showing 2945. Then I just wrote 2945 as a whole in military time. So just showing, going from the 24th hour, we'll go back to 00. So then you got 24 and then 29 with 5 hours left over. So I was like, okay, so that would be 29 hours, 2900 hours and 45 minutes will be 1 day, 5 hours and 45 minutes. And then military time, like if you was to put that in the clock format, that'd be 5:45 a.m. So I was so freaking curious and excited. So I'm like, I wonder if math ever like rolled like that before, right? And then of course my spirit guides, I love them. They always be clutch, right? So they told me that it was called modular arithmetic. And I'm like, you know, that word didn't jump out as like something I've heard of. I'm like, let me just go look into it just to see what's going on, like to see what it is. Because I'm like, obviously I'm on to something. So I was just like, okay. So with the modular arithmetic, numbers cycle back to the beginning after reaching a certain value. So then I said to myself, this reminds me of life and death, energy returning back to source after the body expires. With this modular arithmetic, I tell you, my brain be going everywhere, right? So then I just gave myself an example of this, of the modular arithmetic, just to say that A is congruent to B using modular N. So So I'm just explaining to myself like what this means. I'm like, cause I know since they told me this, I'm possibly finna be using this, right? So that's just my mind frame. Like, let me just buckle in. But anyways, but back to time, going back over here. So like how I broke it down into time. So then 2, 9, and then 4, 5. So we ain't doing military time now. We're going to go back to the 12-hour clock for this on this side. So then 2 plus 9 is 11. And then 4 plus 5 equals 9. So that's why I brought down right here a possible time of 11:09. And then again, my mind always go like, oh, break it down 0 through 9. So then 1 plus 1 would equal 2. And then you still got the 9. So it's like, okay, 11:09 and 2:09 as far as times. And I know for a fact that this means something, and I don't know what, and I know it'll come to me when I need it. So I was like, okay, I'm just gonna write this down because I know I didn't do this for no reason. So then of course every time I do addition, I always multiply because this is opposite. So then I did the same thing. So 2 times 9 is 18, and then 4 times 5 is 20. So then I brought it over military time as is 18:20. So then military time, that's 6:20 p.m. So I was like, okay, cool. Then breaking the 18 down to 9, 1 plus 8. And then the 20, I was curious to myself. I was like, should I leave it as 20? But I was like, why should I leave it though? You broke this one down. You didn't leave that as 11. And I was like, yeah, you know you're right. And I was like, how about this? 2 things can't be true at one time, Jackie. It surely can. So I wrote down both. 902 with the 0 coming first, and then 920, or 920 just leaving it as is and then adding the 0 beforehand. So I was like, okay, so those are 2 times I got from that. And then when you add up time, like the TIME, it equals 20, which equals 2, which got my attention again, this number 20 coming out. And then when I multiplied it, 2 times 9 times 4 times 5 equals 360. And then of course, like, I ain't want to pull out my calculator, right? And I'm weird, and I know this, and I'm perfectly fine with that. So because I didn't want to pull out a calculator, I was just like, boom. I just broke it down like, okay, 5, 4 is too big. Well, it's not too big, so I know 5 and 4 is 20. But I'm like, I'm just going to break all of these down to their prime. So I was like, all right, 5 times 2 times 2 times 3 times 3 times 2. So I was like, boom, 5 times 2, 10 times 2, 20 times 3, 60 times 3, 180 times 2, 360. So I was like, boom. I never wrote my math problem backwards like that before. And I'm like, wait, am I on source energy now? Am I operating right to left? Weird. No, I'm just kidding. But I'm just like, that's kind of cool. So then anyways, moving along. What I got? Oh, still thinking about the modular arithmetic. We're just showing on a 24-hour clock how, okay, you don't have to worry about that. That's for me. Then I got a little download within this too, because I'm like, because it kept telling me to change the time of day. And I was like, time of day? What? So then, boom, I went in, plugged in time, and which was the time that I got from over here. Oh, up here. I don't got to turn the page. 5:45 I got for the first time. So that's why I plugged it in. But I was like, it might be an equation. That's why I did is over of. Da 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 da. But I didn't finish solving it. I just wanted to set up the variable just to see what it would look like. And this was the variable. But it was just a message within itself. But that was for me. Boom. So then, let's see. I'm just giving myself some examples of the arithmetic, the modular arithmetic, just to make sure I understand. And this is when I started overstanding this, right? So here's an example. So like, say suppose today is Tuesday, right? And you want to find which day of the week it would be in 100 days. So from Tuesday to try to like say like what day of the week, Monday through Friday or Sunday through Saturday, what day it would be. And then I'm like, okay, cool. So this is what we finna do, right? So we know what we already have is 100 days, right? Then we know that there's 360 days in a year. So I'm like, that's 2 variables right here that I already know. And then just showing here like the different modulars that you can use, like when you want to do like with shapes or geometry, the days of the week, time, months, even the letters in the alphabet, they all follow a modular. And then I was like following a pattern, and then I went in ahead myself and applied it to biology, which I'll show you, like I'll show you. But anyway, so this is how I worked this out, right? Boom. So the answer would be just using the modular arithmetic method. So it's not, you're not really solving for an absolute answer. It's always going to be a number and then a remainder. If not, it's just equal to. So the first thing to try to figure this out, so as I said, we already know it's 100 days, 360 in a year. So I'm going to divide 100 days, because I'm going to ask myself, that's what I'm saying, how many times does 7 days go into 100 days? Simple division. Boom. So 100 divided by 7 is 14, right? So it's like, okay, 14 times 7 equals 98. So that'll give you 98 cycles, or however you want to look at it, with the remainder of 2. So the answer for this will be Thursday, because with this 2, all you're doing now, because you know that it's going to be a constant cycle, and then the only thing that's left over is 2, so you're going to take that 2, and then apply 2 days to Thursday. So Tuesday, Wednesday, Thursday. So the answer would be Thursday. So I did an example of like each, just to make sure, like, you know, I understand. Boom. So then I tried it again, another one with the spinner. So it's like, okay, imagine a spinner with 8 equal sections numbered 0 through 7. If you move 35 spaces, where do you land? So I was like, okay, just using that same modular example here that I've been following. I was like, okay, so we know that there's 35 pieces. You have 35 spaces to move out of 8. So you got to move in 8 spaces, 35. I'm confused eating my words, but if you can read that, boom. But anyway, so we know that there's 8 equal parts in there, and then 35 spaces. That's what I was getting at. So it's like, you got your 2, so you could pretty much see how you're going to set this problem up. And then let's see. So then so divide 35 by 8, so you don't have to do the actual division problem. So 8 goes into 35 4 times, so that'll give you 32. So from 32 is 35, so they'll give you with the remainder of 3. So it'll give you, the number will be 4 with the remainder of 3. But the way that I understood the arithmetic, I think I wrote down a simpler definition. Just pretty much, I don't know where I wrote it at. Hang on. I don't know. It's somewhere in here. But anyways, I was just pretty much saying, like, when you're going to go plug in these numbers for the modular arithmetic, you don't count this part, the first number. You only include the remainder back into the equation. And that'll make more sense once I find out. Oh, I think I wrote it down right here. Oh, I told y'all, I'm like, my brain's half asleep. I think I've been up for too long. So I was just saying, like, so basically in modular arithmetic, ignore the completed rotation. So that's the cycle. So the completed rotation is 4, because 4 when so it's 8 went into 35 4 times. So that'll give you your first number. And then what I was explaining was the remaining number there. So I was saying, so basically in modular, so basically you ignore the completed rotation and only add the remainder back into the equation. And that was like the simplest way, like on pattern, that I just knew to just, like, that helped me remember. Because I'm like, you know, keep looking at that first number, but you just do nothing with it, like with this. And then, all right, so this is the one I was saying here that I was asking myself, and then I went and solved it myself too. And just know I'm so happy. So I was asking myself, so I was like, so could you use the same, so could the same method be applied to a constant breathing rate, assuming that there's no outside factors to affect breathing, like sleeping, temperature, or like emotions and things like that, anything that could affect your breathing, being startled, things like that. So I'm like, just assuming there's like a constant breathing rate. I was just trying to see, like, you know, is there a way to just try to see like how many, I know that, you know, you can check blood pressure and things like that and blah 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 blah, But I just want to see if that can be applied to this too with the modular. So boom. So I was like, if a person takes 15 breaths per minute, and then every breath takes the same amount of time, how long is one completed breath cycle? So the answer is 4. But I'm going to show you how I got it. So then you just set up a basic equation. So breaths over second. So you're just going to divide the number of breaths into seconds. So what we have from this equation is 15 breaths. They take 15 breaths per minute. So, but anyways, and then there's 60 seconds in 1 minute. So then what I did was divided the breaths by the seconds, and then I got 0.25. So that gave me breaths per second, right? So then I'm just curious because about the frequency rate. So then I times 0.25 by 60 and got 15. So this tells me that the frequency of the breath rate is 15. And then just dividing 60 into 15 from what I got from here. Just one more step now. 60 into 15, that'll show you how many breathing cycles yeah, how many cycles of breathing per second. And then just showing you like this is how I worded it or phrased it. So after I finished that, I said there's 15 breaths per minute at a rate of 0.25 breaths per second in every 4 cycles. Just to answer my question that the person takes 4 breaths to complete 1 cycle. Or however, whatever. I'm about to go to sleep. But if this made sense for you, hopefully it did. I took a late nap and then I was up working and doing this all night and having fun doing so. But yeah, it's right here on the paper. So if y'all need me to go over something or got any questions about it, I can probably clear it up for you if there was something confusing to you. And then this right here, I found this online. It says that this was a mystery that fascinates mathematicians or whatever. But they was asking about the prime numbers. We know what the prime numbers is, but they're saying like the patterns don't repeat in the same pattern like how it was showing with, it was something else I had going on. Oh, over here. So I was looking at this, just going back, revisiting number theory, factors, prime numbers, and things like that, right? Just a little refresher. But then just looking at the example of prime numbers and then the prime numbers at the power of 2. So it's like, okay, 2 to the first power, and I did all the way down to 2 to the 8th power, because once I got to 2 to the 5th power, I noticed that there was a repetition. So if you can see 2, 4, 8, 6, and then if you just look at this last row, the same numbers repeat, and 2 to the 5th, 2, 4, 8, 6. So I'm like, okay, that gives that beginning and the end thing again, where it returns back to source. So I'm like, so that even goes like, you know, with numbers, and then that even like makes me think about music, calendars, horoscopes, and then like time. Like you can just start to see like how everything runs off a pattern and a frequency, and that pattern and that frequency, that it's on like a never ending repeat cycle. And that's like the best way I can explain it. But it's just like seeing like the inner workings of the universe. But I'm about to go to sleep. I probably look like a crazed woman. I already have my coffee to knock me out, so don't worry if y'all don't see or hear from me today. And I probably just take a little cat nap, because my body don't even be needing no much sleep since I jumped through this last little timeline portal. I only get like 2-3 hours of sleep, and I'll be right back up like, dang it, go back to sleep, girl. But I'm really finna get some sleep. But I hope everybody's having a great day. And again, if you do have any questions about anything I was either stuttering or falling asleep on, just hit me up. But I know if I go to sleep, I wouldn't have the same energy for this video. And then I'll be like, oh, wait, what did I write? What was I talking about? What were we just talking about? I love you guys. Have a great day. Ashe.